So here we have a scatter plot, all kinds of data here. Look at all the data points. There's so many of them. And we're going to talk about, that's what we're talking about today, scatter plots and lines of best fit, how to get a line through all this mess. Commonly in the real world, graphs we draw after collecting data won't be linear. What we've been doing so far, everything's fallen in a nice, beautiful, perfect line. And that doesn't usually happen. The data is usually scattered all over the place. Sometimes it's a straight line, sometimes not. Let's look at these two scatter plots here. So they're both talking about comparing the height and the age of students. So is there a relationship between your height and your age? And this one is height and time to travel to school for high school students. So is there a relationship between your height and how long it takes you to get to school every day? So of course there is a relationship here. Look at these dots, they're pretty close knit, they're pretty tight together. There is definitely a relationship between height and age. If we're starting at 5 years of age and then going up to about 20, definitely there is a correlation there. Okay, it's an increasing pattern, and a pretty tight correlation. But over here, there's no connection between how tall you are and how long it takes you to get to school every day. So the points are scattered all over the place. There's no relationship between them at all. The taller you are doesn't mean the further you are living away from home. So that's why the points on the first one cluster together and on the second one they do not. So we have a lot of vocabulary today. And if you're looking at your handout, on the top of the handout, there's vocabulary. And we're going to go through all those words as we go through today's lesson. Data that form a relatively straight line like this on a scatter plot, that's a linear relationship. The second graph above shows a non-linear relationship. There's no relationship there at all. It's not even non-linear, it's nothing, right? There's no pattern there at all. A line of best fit is the line that can be drawn through the set of data so that there are roughly an equal number of plotted points on each side of the line. The line should be drawn in the same direction as the data seems to be going. So I'm going to draw a line here on the first graph that does have a relationship. So normally I would use my ruler. It doesn't work that well here, but I would not draw, for example, a line like this, right? That line does cut the data in half, which is right here, an equal number on each side. So that is pretty close to that. But if you look at the other piece of information here, the line should be drawn in the same direction as the data. And the data is not going straight up and down. So I'm going to erase that black line. So on your sheet, I want you to draw a line that you think cuts the data in half, but also is going in the direction. So maybe more like this. That would be a line of best fit. So that's what a line of best fit is. It best fits the data. It's not perfect, but it's the best fit. Example 1. Adriana drew a scatter plot and 3 different lines. Which line is the best choice for the line of best fit? So it's all the same. It's your wrist circumference. So right now, if you put your one hand around your wrist and see if you can touch your fingers, that distance around your wrist is your wrist circumference, and your height. So is there a connection between the two? So all the red dots are exactly in the same location on all 3 of these. The red dots are all exactly the same. It's just the lines that are different. So you can see there is a relationship because the dots are kind of all going in the same direction. And all these bluish purple lines are also kind of going in the direction of the data. They're all going up, which the data is going up. So the taller you are, the bigger your wrist circumference. So as height increases, so does your wrist circumference. So this is the right direction. But which one is kind of cutting the data points in half so that it's going, not only is it going in the right direction, but it's also got about half the points on either side? Which one do you think is right? B is the best choice because the line is going in the direction of the data and it splits the data points roughly in half. If the data doesn't show the trend for a line of best fit, that would mean the trend, that would mean there's no pattern, right? The dots are scattered all over the place. Sometimes the coordinates in a scatter plot show a relationship modeled by a curve of best fit. The curve, however, must be a smooth curve. So now we're talking about a curve of best fit, not a line. Sometimes in your data, you'll see an outlier. There's another new word. This is a point which does not fall into the pattern that the rest of the data is showing, and we can ignore it. Let's draw a line or a curve of best fit for each set of data. Okay, first one, we're talking about an arrow. This says time, it's really blurry. This says time down here, and this is in seconds, so half a second, 1 second, there's 2 seconds. And this is the height. So an arrow has been shot, and here it's about 3 meters. It goes up to about 5 meters, and then it comes back down again. So that's certainly, I can't draw a line, that's not a line of best fit. And when you think about an arrow, that wouldn't be linear. I wouldn't draw a line like this because as time increases, the arrow is not going to keep increasing in height. The arrow is coming back down again. This is a great candidate for a curve of best fit. So I'm going to try and draw a curve here. I haven't got a starting value on my y-axis. I'm not sure where it starts. So I'm just going to kind of go like this. And this shape, this kind of upside down U shape, we talk a lot about this shape in grade 10. It's called a parabola. You don't need to know that. So that would be a curve of best fit. So it's a smooth curve, and it kind of hits all the data points. I missed a few, right? I didn't hit this one, and I didn't really hit that one or that one, but I'm pretty close. So curve of best fit, if we look up here in the definition, it's got to be a smooth curve. So I don't want to be doing like a, let me erase this. I don't want to be doing like a jaggedy thing where I'm just trying to do a connect the dots like I'm in, you know, kindergarten and I'm trying to connect all the dots. This is not connect the dots. This is supposed to be a smooth curve. So you shouldn't be lifting up your pen and changing really like that. It should just be a smooth curve. So let me try again. Curve around and down. And I might miss a few points, so that's okay. B. Is this a line of best fit or a curve of best fit? This could be either, right? It looks like it could be either. I could fit a line in there. I could also fit a curve in there. So this is an interesting one. Almost any time you have population of animals, it's not usually linear. So this is the year, 1980, 88, 98. I think that's 88 and then 98. And this is the number of animals in this case caribou. This is a little break in the graph because we didn't start at year 0, we start at year 1980. So this, I would put a curve in here. Population is almost always exponential growth, whether it's population of animals or population of bacteria or population of a virus or population of people. So it's usually exponential. It starts to grow quickly and then something happens usually and it stops. But a portion of the graph is often exponential, which is this kind of curve that we talk a lot about in grade 11. So you don't need to know the word exponential, but usually just keep it in the back of your mind. Often when it's a population question, it's not linear. So I'm going to try and draw a smooth curve like that. What about C? Price of a certain model of used car. So here's how old the car is, age in years, and here's the price. I know that's hard to read. So a 5-year-old car, its price is still pretty high. 10-year-old car, it's getting down there. By the time it's 15 years old, we haven't even got any points. So this is coming down. So for this question, I would accept either a curve or a line. You could do a curve. I would kind of start here in the space. We don't have a starting value. I don't know exactly what the price, does it start off? Is it a $20,000 car? Is it a $17,000 car? The question doesn't say where we start. So I might kind of start up here, and you could do a curve like this. It looks like it's curving down, but you could also argue that it's linear, that it's coming down straight like this. So either answer would be okay with me. If I was doing if you're thinking a curve, maybe like this, where I've got about half the points above and half the points below. If I were doing a line, that would be more like that. So for that one, I think either answer kind of fits. So here's our third and final example. Here are the ages and annual incomes of 11 people in one extended family. So let me just go over some vocabulary there. annual income means how much money you make in a whole year. That's what annual means. So here's your income in thousands of dollars. So this person who's 25 years old is making $35,000 in a year. That's what annual income means. This person who's 33 years old is making $36,000 a year annual income. So we've got 11 people in one extended family. Extended family, so your immediate family is your brothers, sisters, and parents. That's your immediate family. Your extended family are your grandparents, aunts, uncles, cousins. That's extended family. So we've got 11 people in one extended family, and these are all of their ages across here, and they're all in order from low to high, 25 up to 60. And this is how much money they're all making. Decide on the dependent and independent variable and label the axes accordingly. Okay, so we're going to graph this. First of all, when we look at a chart, almost always when you're given a chart, I've told you this before, in your textbook they usually give you the X value first and the Y value second, and you don't even need to think about it, but we're going to think about it. Age is in years, and that is anytime you really have a time value, it's going to be your independent. That's independent. And we're saying their income is dependent on their age. So we know what's going to be X and what's going to be Y. Let's look at the X values first. Our lowest X value is a 25. Our highest one is a 60. I have to get from a 25 to a 60 on this. This is my X axis. So I don't need to start at 0. I don't have any babies making money here, or any teenagers even making money here. So I only really need to start at 25. So right here, let me just label, this is my axis, this is age in years. So age in years. So I'm going to start at 25. So I'm going to condense or compress my axis. And what that means is I'm going to put a little zigzaggy thing here. And what that symbolizes is if I had my hand right here and this one is stopped, okay, I'm not pretend there's a stop sign there, I'm not moving that one, but I'm pushing in this direction, and as I'm pushing in this direction, it's getting squeezed down here, it's getting pushed down, so the whole bunch of grid lines are all squished into this space right here. So that's what it means to compress the axes. So I'm going to erase all this up. So now I don't need 0 in there, and I don't need any numbers in the teens in there. I only need to start at 25, and I'm going to just move it over here and put my 25 here. I could have made a bigger compression there, but I didn't want to get too scribbly. So 25, and if I count them out, 30, 35, 40, yeah, I can count by 5s. I'm going to label every second one. So this is 35, whoops, 45. So I'm counting by 5s, but I'm just labeling every second one. 55, 65, I mean, I don't even need 75, but I'm going to put it on there because I don't have any 75-year-olds in this family working. Okay, now for the y-axis. So here's my y up at the top. My y-axis, that's my dependent, that's the income in thousands of dollars. So take a look. What's the lowest income number? Does the youngest person, the 25-year-old, make the lowest amount of money? No, this is the lowest number here. The 32-year-old, one of the 32-year-olds is making $34,000. Who's making the most money? Is it the oldest person? Are they making the most money? Close, but no, they're not making the most money. The 28-year-old is making a lot of money, $75,000 a year. So that's my low number and my high number. So I need to make sure I can fit a 34 on my y-axis and a 75. So again, I'm going to compress my axis again. So I'm going to do a little zigzag thing here to show that I'm squishing it all down. And I'm going to start at 30 because I've got to get 34, but I'm going to count by 5s again. But I'm going to label every second one, 50, and then I'm going to write a title on the side of my axes there, which is income. All right, let me erase some of these marks I made on the graph. Okay, so that was part A. We've got our axes, and takes time, and you have to take the time to label your axes and to spread everything out. Because now when I go to plot them, when I go to put these points on, it's going to be really fast because I've got really nice axes laid out there. So first I'm going to plot my first pair of points here. This is my first pair. This is my X, 25, and this is my Y, 35. And this is part B, create a scatter plot to display the data. So on my X-axis I go to 25, then I'm going to go up to 35, and I'm going to put a dot right there. So let me use green for that. 25 and 35. There's my first plotted point. My next one, so this is my second pair here, 28 and 75. So that's a little harder to do. 28, I'm not really sure where to put that, but that's okay. I'll just estimate my best. And way up, this is that 28-year-old male or female making a lot of money. So this person is really not following the trend of the rest of their family. They're making $75,000 at a young age. So I think about here might be a dot for that one. So I'm going to keep putting my points on, and you do the same and press pause and then come back. So there's our points. Create a scatter plot to display the data. We have done that. Draw in a line of best fit. So let's think about that line, it says, and not a curve. So we're going to have to do a line. Remember, the rules for the line is that it has to go in the direction that the points are headed, and it has to kind of cut them in half. So I would be drawing a line, I think like, whoops, that was a bit low. Maybe like this, except it would be straight. So a line like this, I just tried to use my ruler several times and it didn't work. So I'm going to do this freehand, but you need to use a ruler to go through the line. So I'm going to try and draw it in the direction of the lines, and I'm going to try and get about half on either side. So maybe like this, except it should be straight. So you would use a ruler and do that. And it's not going to be exactly the same as mine, but it's headed in the right direction. It's got about half of the points on either side. So this is a weird one right here, right? We're going to talk about that when we get to F. Describe, as I'm on D now, describe the relationship between the data. So when the question says the relationship between the data, that means, so you always start off by saying whatever is your independent, so age. So you can start by writing as age increases, that's what I'm going to write first. So as age increases of the people in this extended family, as however old they are right now, as the age increases, what's happening with this? That's the next part of your sentence. So as age increases, usually the other part of your sentence is income, and then you would either say it decreases or increases, and in this case it's increases. So except for this crazy one up here, mostly all the people, the older they get, the more money they're making. That's the relationship between the data. So I'm going to write that down there. As age increases, income increases as well. E. Interpolate. Remember this word? This is one of the words that's on our vocabulary list on our handout. Interpolate. At what age would a person earn roughly $40,000? So interpolate means we're going to look in the data. We're going to look in the line. So 40,000. Where do I find that number? I don't have a 40,000 anywhere on my axis. So does that mean I'm going to 40 here? And I'm looking at what's happening at this 40? No, because that's age. And this isn't when a person is 40 years old, it's when a person earns $40,000. I don't have anyone in this family making exactly $40,000, so I'm going to look within my data, inside my data. I'm going to go up here to 40. I'm going to go across to my line, so I'm going to put kind of a dotted line here to show you this. I'm going across the 40 line here, and I'm looking at where I hit my line of best fit. Yours might be in a different spot, that is fine. And then I'm coming down from where I hit, and then whatever spot I think this is here, this is my answer. So for me, I would say maybe 36 or 37 years old, it looks like. So according to this line of best fit, people are making $40,000 when they're about 35 or 36 years old. When a person is about 36 years old, they're making about $40,000. Okay. Next, are there any outliers? Here we go. This is where we're going to talk about this point up here. This is an outlier. An outlier is another one of your vocabulary words. So an outlier is a point that lies outside of the data. So it's way up here. So this 28-year-old person, they're making $75,000, which is more than anyone else in their extended family is making. Even the person who's been possibly working the longest is making $72,000. This 28-year-old, I don't know what his or her job is, but that's an outlier. So that point, I didn't really consider that when I was drawing my line of best fit. I ignored it. I didn't use that to make me move the line up or change my direction or anything like that. Outliers, we ignore them when we are graphing. So the outliers, there is an outlier, and I'm just going to write the coordinate. The outlier is at 28 and 75. So that's the outlier. G, find the equation of the line of best fit, use the slope and y-intercept. So I need to find the equation of my red line. Here's my very important formula for the equation of a line, y equals mx plus b. Well, the first thing I want to do is find m. So m is equal to, you have the formula memorized, y2 minus y1 over x2 minus x1. So I go up to my line, not to my chart with the data in it, because not all those points are necessarily on the line. So I go up to my line and I find 2 points. Now I didn't actually go through any points, so that makes it a little bit harder. If you actually see past through this point here, then you could use this one as one of your coordinates here. So I'm going to just go on my line and I'm going to label a few. And I know your line isn't the same as mine, but you may as well use the same points I'm using just so that we get the same values. So I don't even have any that cross directly through the intersection of grid lines. So I'm just going to take this one here, which I think would roughly have coordinates 55, and then the y value, let's say that's a 63. Whoops, I put 2 commas in there. 55, 63. Now I need another point. I'm going to pick this one right here. So that one looks like it's about maybe 41 and 45. So now I'm going to sub into the formula, and I'm going to take 5 seconds to label those red coordinates with x1, y1, and x2, y2. This is my first x, this is my first y, over here is my second x, over here is my second y. They're actually in grade 9, it doesn't matter if I had rearranged those and made this x2, y2 and made this x1, y1, it wouldn't matter in grade 9 for what we're doing. We'll get the same answer if we mix them up, but it does matter later in math. It's really important that you read from left to right, and when you're doing a bunch of different things with the graphs, it's important that you're always going from left to right. So that's what I'm trying to get you in the habit of now, of calling your x1 and your y1 your first coordinate on the left, and your x2, y2 is your second coordinate after that. But you would still get the right answer if you mixed up your coordinates. However, it is important form for me that you don't, so I will take marks off if you aren't putting them in the right order. But I'm just telling you that in case you see other people in other grade 9 classes doing it in other ways, and they say my teacher says it doesn't matter. It's true, it doesn't matter, but it matters for me. So my y2 is a 63. My y1 is a 45 over my x2 is a 55, and my x1 is a 41. So I've got to subtract those numbers. So what is 63 subtract 45? We'll put that in the numerator and we get 18. So of course you may not have the same points I do because your line is different and all that, but if you just follow along with me, we'll try to use the same numbers right now. 55 minus 41 is 14. So I can divide both of those by 2, and yeah, I'm gonna have to put it beside here. So I'm gonna divide both of them by 2, and I get a 9 over 7. So that's my slope. So right in my equation now, I can put y equals, and I'll just switch colors here, This is the 9/7 that I just found. And then back to red, x plus b, right? What I just found was m. That's m. Now, how do I find b? Do you remember? It has only been a few lessons. How do we find b? So the first thing we had to do was find m, find the slope. Then the second thing we do, we have to sub m in, which was our 9/7, so I'll write that in, sub in what we get for m, and then now we're on our step 3, which is to find b, and the way we find b is we pick a point and sub in. So I'm going to pick between my 2 points that I wrote up there in red on the graph. I think I like the 41, 45 better. So this is an x, this is a y. I'm going to sub them in, and I'll use a different color even for that. So my y is a 45. I'm subbing in this point right here. My y is a 45, and then I've got my 9/7. My x, I'm subbing in for x, that's a 41. 41 goes there, plus b. So now I've got to do a little bit of multiplication. This is 41 over an invisible 1. So I'm going to multiply numerator times numerator, so that's 9 times 41. So I'm going to run out of room again. I've got 369 over 7 plus b. So let me move, where do I have room here? I'm going to move up here. So I'm going to bring my fraction over. So I have 45 minus 369 over 7, and that all equals b. Remember that 45 is over 1, an invisible 1. So we need a common denominator. That denominator, of course, will be a 7 because it's the only denominator. So that makes it really easy. So my second numerator is okay, 369. That's already got a denominator of 7. So what did I do to this 1 to get to this 7? I multiplied by 7. So I have to do the same to this 45. I have to multiply it by 7. So 45 times 7 goes on the numerator. That's 315. Now I have a common denominator, and I can subtract 315 minus 369, and I have negative 54 over 7 equals b. So I just wanted to erase a bit there. So that's the same. I'm going to make that a mixed fraction, because when we are graphing, mixed numbers make a little more sense. So that's negative 7 wholes, and we've got 5 7s left. That's my b value. That means if I hadn't compressed my axis here and here, if everything was counting from 0, my graph would cross. It would cross the y-axis at negative 7, which doesn't really make sense. If a person is 0 years old, they're not making negative $7,000. I mean, whatever that means, right? They're not $7,000 and more in debt. But the math that we're doing doesn't know we're talking about a problem with people, an issue with how old you are and how much money you make. The math doesn't know that. The math is doing the math. Y equals mx plus b is doing what it's supposed to do, which is it's taking this line, this red line that I drew, and it's returned it into an equation. And if it didn't have anything to do with income or age, this equation would have a y-intercept down here below 0. So don't think, oh, I got something wrong. That doesn't make sense. It does make sense because it matches what my graph would be doing. So my equation of the equation of my line of best fit is y equals 9 over 7x minus, I can put mixed or improper, I'll put mixed, minus 7 and 5/7. That's the equation of my line of best fit. That was 30 minutes, not too bad. When you are doing your homework, please watch these lesson examples again, and they will help you. The second time through always makes a lot more sense than the first time through. So take the time, watch the video again, do the examples as you're doing your homework if you get stuck. And as always, let me know if you need any help.